Let us look over this question from the Additional Maths 2012 on vectors. I have quite a bit of an information given, so the way to start with is to just label on the diagram the vectors that I know from here. So I've been told that OA, the OA is a vector A. And also I'm told that OB is called B. I am given some information of the position of the point B as being 5/4 OB. So I'm also told that OP is 5/4 OB, so 5/4 for B. So I know the vector OP, as well as AQ is 1/3 AB, and the vector AB is B minus A. So I know AQ, and I also know OP. Sometimes it's just draw them on the diagram to remember what I was given. So my first question now is find OQ and PQ in terms of A and B. OQ is, so to go from O to Q, I can go from A to O to A. See how easy is it now to see when I have colored on the diagram the vectors that I know. And then I go from A to Q. So it's A plus, and then to go from A to Q, I have 1/3 B minus A. So it is A plus 1/3 B minus 1/3 A. So it's 2/3 A plus 1/3 B. The next vector that I need to find is PQ. So to go from P to Q, I need to go from P to O, and then from O to Q. And we remember that we just found OQ, so see how these questions are related to each other. So PO is minus 5/4 B plus OQ 2/3 A plus 1/3 B, which gives us 2/3 A minus 11/12 B. Second question asks to find QR in terms of lambda AB. So if they say lambda AB, I shouldn't have other letters like mu or something else, only lambda AB and numbers. And now I'm told that OR is lambda OA. So see the lambda appears in the expression that I need to find. So I know OR. Therefore, to go from Q to R, I can go from Q to O, and then from O to R. And I can write that QR equals QO plus OR. QO is the one that we found here. We just found OQ. So QO will be negative 2/3 A minus 1/3 B. So negative 2/3 A minus 1/3 B plus OR, and OR is lambda OA. So I get lambda minus 2/3 A minus 1/3 B. Next question is a bit more difficult because it asks me to calculate QR, same as in the previous question, but now in terms of mu A and B. And mu appears here, QR in terms of PR. So in order to use mu from Q to R, I shouldn't use the R root, or I need to get to R, but I need to get through P, because I know something about PR. So I'm starting by writing that QR equals mu PR. And now, how do I get from P to R? Some of you wrote by mistake that I should continue by negative 5/4b plus a. And why is it wrong? Because if you go from P, negative 5/4b brings you in O, but then plus a brings you in A and not in R. So therefore, this is incorrect. Okay, so going back, I write PR as PQ because I know it, plus QR. I don't know QR, but I can form an equation because I have QR in the left hand side and QR in the right hand side. So if I open the brackets, I'm going to write on the next slide, QR is mu PQ, if we open the brackets, plus mu QR. Therefore, QR minus mu QR, if we subtract this expression from both sides, will give me mu PQ. So QR bracket 1 minus mu equals mu PQ. Therefore, QR gives me mu over 1 minus mu PQ, and we found PQ in the first question as being 2/3a minus 11/12b. The last question asks to find the values of mu and lambda. Let us remember that we found QR in two different ways. Once using lambda and the second time using mu. Just to stress it out again, if in this question in the expression of QR you have the lambda, you don't get any marks because they ask you to express it just in terms of mu and b, so no lambda. This one is the correct representation. So going back to question 4, we have QR represented in two different ways. And in both ways, it is decomposed on the vectors A and B. Vectors A and B act like bases for the set of vectors in the plane. So QR can be uniquely decomposed onto given vectors. So if you have the vector QR, you can't write it in terms of A and B. You can write it just in one way in terms of A and B. Therefore, these two representations must be the same, this and this, right? And they are the same if the coefficients of A in both are equal and the coefficients of B are equal. So from here, you have the equations lambda minus 2/3, which is a coefficient of A in the first equation, equals 2/3 mu over 1 minus mu. And the second equation comes from the coefficients of B, so mu over 1 minus mu times minus 11/12. As you can see, the last equation is easier to solve because it has a single unknown. Yeah. So the first equation reduces to a linear one, and you get mu equals 4/15. You replace in that equation, which I called 1, replace mu and find lambda. We get lambda equals 11/10.